Good morning. As Josh noted, my name is Amy Gross, and I work for L3 Harris Technologies as a sustainability principal in their Space and Airborne Systems segment. I am also an active DART board member. I'm really proud of that. And prior to joining L3 Harris this year, I was at Joby Aviation for 5 years, which was an incredible experience, amazing company. For those of you who don't know who L3 Harris is, we are an agile global aerospace and defense innovator of technology. We offer end-to-end solutions to meet our customers' needs. We provide defense and commercial technologies across air, land, sea, space, and the cyber domains. One of the things that I loved about working at Joby, about being in this area especially, is this idea of anything reinventing possible, which is something that Joby says. And one of the things that we just heard from Mr. Donovan was about people not having something in the realm of their experience and things that are just not possible. And that's what's so exciting to me about being here on this panel today, is that they are all reinventing possible. So it's my pleasure to moderate this panel of exploring these technologies, leading technologies in advanced air mobility with practitioners who are so deeply rooted in the field. We're using a liberal definition of advanced air mobility, AAM, to include uncrewed mobile systems for goods and services, as well as piloted eVTOL aircraft being developed by Joby Aviation and other companies. We have an esteemed panel this morning, including Joshua Resnick, CEO of Parallel Flight Technologies, Kellen Mollahan, Commercial Operations Lead for Joby Aviation, and Dr. Raja Sengupta, Professor in Systems Engineering, Civil and Environmental Engineering at UC Berkeley. They will all have an opportunity to speak about what they're working on and a little bit more about themselves. But if you're interested in more information, you can go to our event website at montereybaydart.org for some look at some detailed bios. The format of this panel will allow for all of our panelists to give some opening remarks, share some information about their work, discuss business opportunities, practices, some of the challenges in scaling and realizing a robust AAM market. And then we'll engage in a moderated discussion with some pre-formatted questions. And then towards the latter part of our session, we'll open up the floor for questions from the audience. You can use the slido.com app. For those of you who haven't noticed, there's agenda cards on each table, and there's a QR code to tap into Slido, so you can ask your questions there. And feel free to ask those questions anytime during the session. Questions that don't get answered today during this time will be stored for follow-up. So to get us rolling, I am going to introduce Joshua Resnick, Parallel Flight Technologies. Welcome, and take it away.
Thanks a lot, Amy. And what do I have, 10 minutes? Is that right?
Yeah.
Okay, cool. I'm going to stand up while I do this, because that's just what I do. So good morning, everybody. Thanks for coming. I am Joshua Resnick, and CEO of Parallel Flight Technologies. Does this clicker take us where we want to go here?
So.
Perfect. Cool. Before I dig into the slide deck, I'll just give you a quick background. Prior to founding Parallel Flight, I was leading the electrical engineering for the Tesla semi-truck program. So system integration, right? Like, how do you turn some number of Model 3s or Model S's into a semi-truck? So that's what I was doing prior to this. And before that, I was up in Alaska doing some hybrid stuff with fishing boats. So just a little background on myself. Super excited the Tesla truck is going to launch to their first customers tomorrow. So if you didn't know about that, check it out. It's going to be pretty cool. Anyway, I'm here to talk about Parallel, not Tesla. And what are we trying to do, and why are we trying to do it? First of all, the problem that we're trying to solve is around vertical lift. This traditionally is done by helicopters, and we started reaching out to a lot of different industries, trying to understand why aren't you adopting autonomous systems when you're trying to do these vertical lift operations? And the answer we got back was that there's some fundamental problems with the technologies that are on the market today. All electric drones, when they're carrying a heavy payload, and when we say drones here, we're talking about vertical lift drones, rotorcraft, so not aircraft with wings. These rotorcraft, when they're trying to lift a heavy payload, if they're all electric, they're only going to fly for about 10 to 15 minutes. You really can't get a lot done in that short amount of time. Then the hybrid and gas-electric drones that are out there, they have longer flight times but can't seem to carry a heavy payload. The autonomous helicopters that are out there are extremely expensive to operate, just like real helicopters, require a ton of maintenance. And forward flight technology, so things like, for example, aircraft that can take off and then transition into forward flight, they're not designed for these vertical lift operations. So these are the problems that the industry is facing. So we have developed a technology stack, and we'll show you what this looks like in terms of an actual product in a minute. This technology stack answers these core problems. So the key technology is our parallel hybrid propulsion system, which enables long-duration vertical lift flight. And the upshot is 50 to 75% lower operational cost, increased safety, and reduced carbon footprint. And it solves all the key problems that we've seen in the vertical lift market. So what does this look like? It looks like this. This is our first product. This is Firefly. Firefly can carry 100 pounds of payload for 1.6 hours, and we believe it's possible to get that to even more than 2 hours. And it solves these different problems with the parallel hybrid propulsion system, which combines the gas and electric power systems into one. So you get the duration of gas, but you also get the maneuverability and responsiveness of electric, and you also get redundancy. So, for example, in if you get a failure in the powertrain, the rotor can keep spinning, and then obviously safety is really our #1 priority. So if there is like a catastrophic bird strike or something really bad happens, then there's a ballistic parachute to bring the aircraft to the ground. But in terms of operations, this is it's a very efficient aircraft compared to other hybrid systems that are out there. It has an autonomous flight controller, so basically from the ground control station you just press go, the aircraft executes its operation. If you need to change something you can, but generally speaking it's fully autonomous. There's and then on the maintenance side, I think this is something that's not really appreciated, but if you're familiar with the helicopter industry, when it's time to maintain a helicopter, that aircraft can go down for a long period of time while you're pulling out the power plant, checking tons of linkages and stuff like that. And that's true for autonomous helicopters as well. With our system, you just swap those power modules on the corners of the aircraft. So your full powertrain reman takes an hour. So it's very very different than other stuff that's out there. Our next product is going to be Superfly. We haven't really, we're focused entirely on getting Firefly to market, but there's also a large market for a heavier lift system. So this is something that will lift over 500 pounds of payload. We're seeing a lot of interest in things, for example, like wind turbine maintenance for an aircraft like this. So it'll be a scaled up version of our technology, more rotors, larger hybrid modules, but essentially the same technology. So we're excited about this in the future. These are the different types of markets that we are actively engaged in. So everything, we started with a really core focus on wildfire and land management, and we still have a lot of traction in that area, and I'll share some of the work we're doing. However, we've gotten so many requests from different industries, and a lot of these are large industries. So for example, power line, utility, and infrastructure, construction, agriculture, defense, wind turbines, all of these different areas. So I'll share some of the core areas that we're working in. So let's talk about wildfire. Dean gave some excellent examples where really good inspection can make a huge difference with wildfire. We're working more on the actual firefighting side of wildfire. So what does that look like with our aircraft? For us, it's doing tactical resupply, so this is bringing key supplies to firefighters in the field, and also doing prescribed fire. So we're partnering with a company that builds a prescribed fire payload. This is a system that drops balls on the ground, they catch on fire. This is used for land management. It's also used to put control lines in during a fire. So we're actively integrating that product onto one of our aircraft. We're going to be demonstrating it hopefully in Q1. And we're working closely with U.S. Forest Service, DOI. We have grants from USDA for wildfire mitigation, so we're actively working in that space. And oh, this is what the Ignis system looks like. That's the system that drops those little fireballs. They're called dragon eggs. So that's a real thing. No, it's computer generated in this image, but we just got that system in our office 2 days ago. It's being put on one of our aircraft right now. The other, here's a military application. This is what we call, a tactical resupply. And in this case, it's a medical payload. So we've worked closely with a division in the Air Force to build out what this application is going to look like. We're basically, it's bringing blood to the front line of a battle to save somebody's life. And they call it the golden hour, right? You've got basically an hour to get this out there. And today, 55% of delays and failure to make a drop is due, because of weather or hostile action. With an asset like ours, that is less of a concern, right? You're not worried about losing a helicopter and its crew. You just want to get the drone out there with the blood. So we're really excited about this application. We've got a lot of support and enthusiasm from inside the military. They approached us saying, no drone that's made by any US manufacturer, or really any manufacturer that we can find, has the specification for what we're looking for, and except for yours. So they approached us, they said, how can we partner? We've designed this application, and it's moving forward, so it's exciting. So I think that's it, right? I don't know if I have any, I guess there's some appendix here. This is an example of CO2 burn difference between helicopters and our aircraft for number of applications. You're looking at roughly a 92% reduction in emissions, and that's just because you've scaled the aircraft properly to the payload, which in many cases is much lighter than the helicopter. And this is kind of a competitive overview of the different technologies that are out there and how they stack up against each other. I think I'm probably out of time, right? So, I think we're there. Okay. Yeah. So, I think that's it. I'll stop there. We can move on to the next presenter, but happy to answer any questions. And thanks for your attention. I guess you have mine. Thanks.
Hi. Is this on? Yes. Okay, excellent. I'm Raja Sengupta. I teach at the University of California at Berkeley, and it's a great pleasure to be here. So we've been working on urban and regional air mobility, and there's sort of, our thinking sort of embeds this inclusive part, which I think you'll see. That is not the right slide.
I think you've got to go the other way.
Oh, I got to go the other way. I'm going into your slides. Okay, there we go. Okay, so the first thing I want to draw attention to is that this stuff, that any, for most of us, an urban air mobility or a regional air mobility trip is not a door-to-door trip. It's a hub-to-hub trip. And it has a non-air first mile and a non-air last mile. And in the results that I will present, these have been cars. But after doing this research, as I've been talking to cities and departments of transportation, they say, it would be, we don't particularly want to use urban air mobility to promote car use. So this may well be America's opportunity to make transit attractive. The first sort of issue is that if you want to develop tools to study this field, it's a very multi-stakeholder, multidisciplinary enterprise. Because of this first mile, last mile business, you have to do ground traffic simulation. So here we have Manta, which is a ground traffic analysis tool developed at Berkeley. And then here there's FE3, which is a NASA air traffic analysis tool for urban air mobility and regional air mobility. You can see that it does detailed trajectory simulation, so you can study trajectory conformance. And then up there, you see how all these things are put together. There's something in the middle in a green circle called VertiSim. So that simulates the vertiport, which is, of course, something completely new that is neither understood in ground traffic nor understood in air traffic. And then we've been focusing on the infrastructure design side to understand, because I have worked in transportation for 25 years now, and in my understanding, transportation is a very public-private business. And that's the only way to make something major work. And so we've been looking at the infrastructure design side that is required, and also there are all these design libraries that go on. And the problem is also that this is a rather technologically complex sort of tools and analysis enterprise, because the scale of air traffic simulation is small, and that doesn't really test your computing limits. But because of the first and last mile, if you want to do regional scale analysis, you have to simulate the ground traffic, what's going on in the ground traffic, and that actually tests the limits of modern day of computing even now. And so a lot of this is GPU fast time computing. That's what all these tools are based on. And we have all of this work is actually done by PhD students at Berkeley who are bridging aerospace and transportation, right? They're putting the two together, and they're here in the audience. So there's Emin, if you'd stand up. There's Pangshin. Where is Pangshin? And there's Xuan, and there's Masood. So we have a strong and enthusiastic UC Berkeley contingent here. So you can use these tools to sort of understand and segment the trip market. Here you can see you see those numbers there: 10, 30, 50, 70, 100. As you increase the number of vertiports, you increase the set of trips that UAM can actually benefit. Here, by benefit, we mean a travel time benefit. And if you have 10 vertiports, you're serving the 60-mile people, the 80-mile people, some of the 40-mile people. But if you really want to get into the 40-mile market, at 30 vertiports, you get a significant chunk of the 40-mile market, et cetera, right? And and then as a broad thing, we try to understand, if we just think of travel time benefit, forget about cost. So let's say costs are 60 cents a mile, the cost of driving. What is actually the set of people in the Bay Area, the set of travelers in the Bay Area to whom an air taxi can provide benefit? So a 4-seater aircraft, and right now we think it's about 1/10, which is really, really significant, right? Because if you move anything over 5% of the traffic in the Bay Area to the air, people who do not use UAM will also experience a benefit, right? Which is the kind of thing that justifies public funding to BART, for example, because even those who do not use BART benefit from BART. And so you can see that, but in order to get to that level, you have to have a pretty large infrastructure at about 100 vertiports. And we have the capability to do this kind of analysis, so we can do it for other people who want it under different assumptions. And then what you're seeing on the right side here is we can optimize vertiport infrastructure, and we can design it to maximize aircraft utilization, because economics is all going to be a matter of filling the aircraft, right? So here we have said that we want to fly with upwards of 3.9 passengers per aircraft. If we release that constraint, we could serve more people. Another thing to note here is there's actually a pretty high operational capacity assumed. So we can also put in an operational capacity limit and do this kind of analysis. Here we've assumed there are 2 TLOFs per vertiport and 2 operations per minute, which is, I think, pretty unprecedented in the air traffic world, right? But we can reduce all this and come up with different numbers. We can optimize vertiports, vertiport layout, et cetera. Here, for example, you're seeing, and this is work done by Amin, we can see that as you make a vertiport more efficient, you need, as you make a TLOF more efficient, the more operations per minute you can support, the larger the number of parking spaces that you actually need in order to fully utilize that asset. So there are all these design trade-offs that we have now learned to do. Okay, so kind of broadening up from the research for a minute, Any new technology, transportation technology needs some context. And, here's the way I think of this. Many of us don't like highways. That's Henry Ford there with the Model T. And here in the middle is the 1919 California Highway Bond. And, that's my denotation of the American dream on the other side. And, thanks to the Dallas Fed, I've been looking at, American urban land prices from 1890. And I think it's really true that the interstate, freeway system and the automobile, delivered the American dream in the 20th century, right? And Dean alluded to some of this. But for a variety of reasons, we seem unable to use it in the 21st. And we are now looking for an alternative. And so I think that green is the context in which this new technology sits. That as we try to figure out, how to continue to deliver a high quality of life to ourselves, should we use rail, should we do transit-oriented development, or should we do air mobility, right? I think it's a very, very multimodal way of looking at things that is needed to make this field move forward. Here's another thing that has a lot of influence in my mind. On the right side, we see California's income by county, and the red is lower income, the blue is higher income. On the other side, we see some of California's airports. The state has over 300 plus public and private use airports. And when I look at this picture, and I look at all those, the dark red and the pink, I don't think the interstate highway system can turn those counties blue, right? And this is not a political statement. This is not at all a political statement, right? That, and it would have done so. I mean, can rail do it? Maybe, right? Yes, I think rail can do it. But I think this is the kind of value proposition that we're looking at. Can this new aircraft technology fundamentally shift the equity of access across communities? And this is something that really motivates us at UC Berkeley. I look at the same thing, the distribution of the airports. If you overlay one on top of the other, you can see California's airport heritage is diverse and it is inclusive. And I think if we focus on this infrastructure, can we create a similar kind of air mobility, right? That is both equitable and inclusive. I won't comment on the traffic distribution in the interest of time. That can come up later. So looking ahead, right, I feel that what we need is a public-private California AM enterprise that spans technology, policy, and workforce development. And in this sense, I feel that what I'm looking at here in this room, what Monterey Bay DART is doing, I feel that we need to lift this up to the level of the state, and maybe even to the level of the nation. And here are some of, on the planning and policy side, I think we need to develop tools and methods for AM to enter state-level planning processes for more equitable access to jobs and services. Same for AM in the MPO process. So here I think the value proposition should be to use the fast mid-mile air to reduce solo driving and increase shared multimodal transportation. I don't think of this as an adjunct to Uber. I think this is, when we try to provision the regional airports with first and last mile services, we should look at non-car services. Cost informs inclusion, right, as Dean pointed out, evolve below 60 cents per passenger mile urban and regional air mobility from the $3 a passenger mile air taxi. That should be the stepping stone. AM infrastructure that maximizes use of existing infrastructure and reduces the need for new stuff. On the technology side, I think the call is really high throughput operations. And there'll be a number of, there's a bunch of numbers here. I feel that, if we look at, let me just leave all those comments in the interest of time. So I look at the kind of things that other modes of transportation provide. And this is the context in which I think about, what are the technology requirements for this new field? How do airports have to operate in the future? Virtual towers is going to be an important one, because if we increase the traffic at regional airports, we will need ways of controlling it, and we cannot just replicate the current infrastructure. And then this is perhaps the last thing I want to comment on, that for California, this is particularly important, because if you look at the global landscape today, 3 of the world's top 5 eVTOL OEMs are here in California, and 2 of the world's top hydrogen aerospace companies are here in California. In California, we understand the benefits of an aerospace economy. We have $60 billion in aerospace revenue today. We have 250,000 direct aerospace jobs and 500,000 indirect jobs, right? I believe that this industry has the same kind of potential. But in order to do this, the public sector and the private sector have to come together. Because if you want to launch a major mode of transportation, you need public goods. The OEMs do the technology, but for roads, you needed highways. For aircraft, you need airports. For ships, you need ports. Even bicycles, we are now giving them bike lanes. So I very much appreciate this whole enterprise at Monterey Bay Dart. I'll stop there.
Thank you, Raja.
Hello, my name is Kellen Mollahan. I'm the commercial operations lead at Joby. And my role as commercial operations lead means that I help the folks at Joby plan and build for the components of an aerial ride-sharing service. And really to ensure that Joby is ready to launch, operate, and scale an aerial ride-sharing service in markets around the world. Now, Joby Aviation is a vertically integrated transportation company. And what that means is that Joby is building and working to certify with the FAA an aircraft like what you see here, which is an electric piloted vertical takeoff and landing aircraft. Joby is also working to build out the air carrier that will operate the aircraft in the aerial ride-sharing service. Joby's vision is to save 1 billion people an hour a day, and we believe that's possible by changing how people move around metropolitan areas, principally by unlocking that third dimension of transportation and allowing people with a push of a button to move from one side of an urban, suburban, or exurban area to another, in part by flying over it. We think this can get people to where they need to go up to 5 times faster than if they had been sitting in traffic, that this is sustainable with an all-electric aircraft that has 0 operating emissions, and that has a very quiet acoustic signature that blends in with the urban soundscape. And we think this kind of a service is beneficial to markets all around the world, and this service can be applied and deployed in markets all over the world. The aircraft itself, which I'm sure you'll hear more about over the next 2 days, it will be piloted by a professional, commercially rated pilot and can seat up to 4 passengers. Because the aircraft can take off and land vertically, it will be able to not only land at existing aviation infrastructure, such as airports and heliports, but also at future purpose-built takeoff and landing sites to support electric vertical takeoff and landing aircraft. The aircraft has a range of 150 miles and a top speed of around 200 miles per hour. So I'm really excited to be part of the team that is working to operationalize this aircraft into an integrated air and ground transportation service that will be available to everyone in the markets that we launch through an app on their phone. And as has been mentioned, we are really focused on the rider experience. And that's so important because for a rider, the journey to get from point A to point B could involve 3 segments, 3 transportation segments. That first mile is how you get from your point of origin to the aircraft. That middle segment, which hopefully accounts for most of the miles traveled, would be in the air, flying over congestion and traffic. And then the last mile is getting to your end destination. And so Joby is building the tools that seamlessly orchestrates and coordinates those 3 segments, allows for any number of modalities in the first and last mile, but so that from the rider's perspective, you're not thinking about the 3 different legs of the journey. You're thinking about a single seamless journey that keeps you in motion. Just some of those components of what we think about for an aerial ride-sharing service are shown here. I apologize for the text moving on to the other line. But Joby is building the tools for the rider marketplace, so how you would interact and book your trip. and on the back end, how that trick is coordinated and orchestrated. Joby is interested in not only ensuring that we can access existing airports, aviation infrastructure, but also finding the right locations to connect communities where aviation infrastructure may not already be. We call them skyports, also called vertiports, but that purpose-built infrastructure. Going back to Joby's vision of saving 1 billion people an hour a day, deep within that is a desire to benefit communities. And so as we think about where and how we'll launch in markets, it's very important for us to be aware of and plan for how not only the service can benefit communities, which we believe it will, but how our presence in that market can benefit communities as well. As Dean knows, air carrier operations are highly regulated. And so as we think about growing as an air carrier, we want to ensure, and we are planning for not just ensuring that we comply with our regulatory requirements, but we are growing the air carrier and scaling the air carrier in a manner that is consistent with safety and Joby's other core values. And that's it for my slides. So it's very exciting to be working at Joby. Thanks.
Thank you so much. Oh. Thank you so much to all of our panelists. We have a couple of questions ready for you here, and then at the same time, like I had mentioned earlier, if you want to submit. Sorry? Okay, we have 5 minutes. So I'm going to go ahead and get started. Joshua, I'm going to start with you. What differentiates your platform from other hybrid systems, and what types of aircraft are you competing against? Will your price point make sense for more budget-sensitive operations like wildfire prevention and suppression?
Great questions. So I'll start with the first one, which is the differentiator. So there are hybrid systems on the market for vertical lift, and they're basically multi-rotors with a generator attached or integrated to the aircraft. And the problem with those systems for heavy lift is that all of the power conversion stages between the generator and the props really limits how fast you can move that energy from the fuel to the propellers. Our system allows a very direct connection. In physics terms, we have a very good power density, whereas the competition has a low power density. So that's kind of a technical jargon for we can use the fuel more efficiently and get it to do the work that it's supposed to do very, very quickly. What was the second question?
Let's see here.
I can talk about price point. Yeah, I can talk about price point. I remember that part. Yeah.
Price?
Yeah, so when you're competing against helicopters, you basically can still charge a lot for your services. Parallel Flight is building itself out to be a drone as a service company primarily. We'll also act as an OEM for certain markets. So when we look at drone as a service operations, we, in many cases, it's a quarter, half the price of a helicopter, even for Superfly, which is our larger aircraft, 50% to 75% of the cost of a helicopter, but with increased safety, higher efficiencies, and so on and so forth. So we never get pushback when we talk about the price of the operations with customers.
Fantastic. Thank you.
Yeah, thank you.
Raja, your team has conducted analysis of AAM potential to affect ground traffic conditions in the Bay Area. It's one of the things I feel like we're so lucky today to have people that are local, and you have done extensive research on this. What are some of the most relevant findings that you during your research?
So I feel that, so I think we've kind of understood the congestion relief argument, and we think it is real. And we've kind of understand the scale of infrastructure that's required, right, in order to achieve something like that. We also think that, the air taxi business is, I think, a very viable business. I mean, it is, I think, going to happen. Will it reach the scales at which it means something? You know, like right now, Blade flies people, right, from JFK to Manhattan, from the Hamptons to Manhattan. It's at such small volumes that it doesn't mean anything to probably all of us here, or most of us here, right? I think Joby's play is something that will touch probably everybody in this room, right? And so to get there, I think the scale of infrastructure needs a process. And that process, I feel, is missing. You know, I kind of alluded to it by saying that, okay, you know, there's a public process creating bike lanes for bicycles. You know, where's the public process trying to produce infrastructure for this industry, right? And how exactly, you know, and any public process has its own value system, right? Is congestion relief the right value system? I mean, will we actually be able to get a politician to invest political capital in making sure the state has a vertiport infrastructure on the basis of a congestion relief argument? Maybe we will, maybe we won't, right? And that's why I threw up the other argument, which I think was also there in what you said, that, you know, this sort of emphasis on communities and access and equity, right? Which in today's political climate have become particularly important, right? And most of us, I think, believe, fortunately so.
Thank you. And Kellen, thinking about locally, what policy enabling actions would help Joby scale faster or grow stronger right here in the Monterey Bay and in California in general, given the current climate and the cost of doing business in California?
Yeah, well, I mean, Joby is so grateful for the support that it's received already from Marina, from the County of Monterey, from the James Irving Foundation, from Monterey DART. And that, just looking at that, that has enabled Joby to spin up its facilities and its operations here in Marina. I think we are really excited about the apprenticeship program, where we've taken on our first cohort of apprentices, local apprentices, to provide education and on-the-job training. And one of the key things to make sure that Joby can continue to grow and scale is for it to be able to meet its hiring needs. And we're really excited about growing programs like that, where Joby can meet its hiring needs while also growing the number of aerospace careers in the Salinas Valley and Monterey area.
Great, thank you so much. I'm going to move to some of the questions that are being answered on, asked on Slido right now. And I will start with the top one, yes. How do you convince the venture funding community that this forward-looking tech is going to happen? Anyone?
I think by getting customers to sign up, place orders, and doing pilots is, you know, a good way of doing that.
Yeah, I'd say the great thing about many of you in Marina is you can see it. You can go to the Marina airport and stand outside the fence and see the aircraft fly, and more importantly, hear the aircraft fly. And I think for a lot of folks, seeing is believing, and so as we mature, the more that we can open the door and allow other people to experience that, it'll continue to put inertia in the development of the system.
Or you cannot hear Joby flying at the airport because it's that quiet. I also think maybe in terms of just the venture funding, you know, there's so much more, as Raja was saying, to this value proposition. It's not maybe just congestion, but equity, and there's also an environmental impact that goes along with that. So I think it makes it appealing on many levels, for sure. Next question. Did you consider the value of the aircraft when you are saying, sorry?
That one is for Dean.
Okay. Should we?
Dean can answer.
I don't know. Okay, we'll move on to one more. Let's see, any plan to develop drone use in confined areas, mining, hazard detection, sports stadiums, customer experience?
So there's a number of companies working on drones for confined space work. So that technology is being developed, and it's pretty interesting. And then, yeah, the sports stadium thing, there's stuff going on in that arena, no pun intended. We've been approached to look at, can you spray disinfectant, on an entire stadium, after a game, before the next set of customers comes in. So that kind of thing is going on. It's not one of the big markets that we're looking at, but it is happening.
Are we at time, Josh? Or okie dokie. Using regional airport for UAM service not only benefit users, but also creates numerous jobs for local areas. What's the vision for the potential industry size?
Okay, I'll take that and the next one. In transportation, right? When you do, as I said, you need to bridge aerospace and transportation here. In transportation, so congestion relief is what people call a mode substitution argument, right? You say that, the trip demand is exactly as it is today. These are the origins and destinations. We look at data from the Metropolitan Transportation Corporation. They say, okay, in the morning commute, there are 3.2 million ODs, right? And we assume exactly that. And then we say, can we provide a better mode of travel for exactly this trip with this origin and destination, right? The question that's being asked here is about the other one, where they say that, once you put in a new mode of transportation that's faster, there's something called induced demand. It will induce demand, right? And one very good example of this is the TGV in France that we've studied at Berkeley. That when the French president said that I want everybody to be within 2 hours of Paris, people thought it would create a lot more development in Paris. No, it actually created development in Lyon. So because now you could just you could set up a business in Lyon, right? You didn't have to set up a Paris office. You could just have your Lyon office. And you could, get up in the morning. Within 1.5 hours, you would be in Paris. And then you could conduct your business meetings. At 3 o'clock or 4 o'clock, you could take another train back and be back home, right? So that's induced demand. The induced demand analysis, in my understanding for this industry, has not yet been done. And I think this is one of the reasons why I think we need an enterprise. NASA allowed us to get a start on the tools. But I think we need to create something that will look at these issues. The reason I said I'd take on the next question as well is that it's trading one traffic jam for another, right? So what many people in transportation will say to you, that there is nothing called congestion relief because of Marchetti's constant, right? That essentially when we were reliant on the horse, we were willing to travel 25 to 30 minutes, sometimes up to an hour. When we switched to the Model T without freeways, we were still doing that. And when we switched to the modern sedan with freeways, we are still doing 30 minutes to 1 hour. And when we put in this new technology, it will still be 30 minutes to 1 hour, right? So, we will free up the roads as we move people to the air, and more people will show up to utilize the roads, right? So that actually falls into the previous one where, the real way to, if you believe that, you would say, Raja, you showed me all this mode substitution, congestion relief work. That's not the right way to look at it, right? Because what's actually the demand will be that congestion relief plus whatever is, that congestion relief will eventually disappear, and it will be all the land use changes, the increased prosperity, the housing that gets built, the businesses that get established, that will establish the demand for this industry. And I hope will fundamentally transform California.
Fantastic, thank you. Well, that's it for this panel. Thank you so much for being here, and thank you so much to our guests. This was really great.